Swayam Prabha. Digital India. Educated India.
Good morning. Welcome to the fourth lecture of this week. We are going through the course on understanding and reducing greenhouse gas emissions, and we are particularly looking at building design and construction, and we are trying to reduce the emissions, the scope 1 and 2 emissions through the same. In this lecture, we are going to look at strategies for refurbishment of emission reduction, Now, why we are talking about this refurbishment strategies is, all this while, this entire course we have talked about, we have looked at different aspects related to building design, starting from passive design strategies to advanced passive design strategies to daylighting, natural ventilation and everything. And then we moved on to construction, where we looked at the different materials, the factors which affect selection of materials, and then we saw the emissions which are related to different materials. We understood what implication would it have on greenhouse gas emissions and all, and this is what we were doing. But the whole idea when we were going through this was that most of this design and construction strategies, they are going to be used for construction and design of a new building, a new facility. So, with that understanding, all this discussion was going on. But if we look at around the globe and also in particular about India, a lot of building stock is going to be needed, but a lot of building stock already exists, and this building stock which exists is existing there, has been there for a long time, more than 50 years, more than 70 years old. Now, in those times there were different technologies and materials that were available, and the design was done differently. So, probably if we look at India, the buildings around 70 years back in India, majority of the buildings were naturally ventilated. The materials that were used were the conventional materials of those times and may not have been as energy efficient. Now, gradually as the time has moved on, we have seen that those naturally ventilated buildings, they have been converted or they have been added with air conditioning, because the climate is changing, the weather is changing, the lifestyle is changing, and the expectations of people occupying those buildings are changing. Now, with this change that is happening, there are two ways. One is to just add on, for example, in a conventional building which is like 70 years old, we can just add air conditioner and continue to air condition the building. Now, this if we are doing, the materials which are there, the design which had been there was not suited for adding the air conditioner, and so it is going to result in a highly inefficient building. The other thing is to completely demolish the building, raise it down and then build it from scratch. Now, when we do that, there we will be requiring a lot of new material, a lot of resources that are going to go in this new building, and then we are going to construct this, which might be highly energy efficient building, but the embodied energy that will go into this new building will be extremely large. The third option is that we refurbish the building or retrofit the building in a manner that this building will now be suitable for air conditioning. Here we are looking at this example. Now, this refurbishment will reduce the operational energy consumption once it is refurbished. At the same time, it will require less amount of resources, because the building skeleton, the structure is already in place, it is intact. All we need to do is we need to refurbish it to suit the air conditioning. So, this is where everybody agrees that refurbishing, retrofitting of old buildings is going to bring us tremendous savings in terms of embodied energy as well as operational energy, and a lot of retrofitting and refurbishment is already happening across the world. So, in today's lecture, more or less the design and construction, the understanding of that remains pretty much the same. All we are going to do in today's lecture is we are going to understand what are the various types of strategies that are available and what are those strategies that we can incorporate. Now, quickly looking at what we did yesterday was we looked at the different sources of energy, and then we looked at the carbon footprint of various sources of energy, and the intent was to move towards the renewable sources of energy from the conventional hydrocarbon based sources of energy. In this lecture, we are going to understand the subtle differences between refurbishment, renovation and retrofit, strategies for each of these, emissions from renovation versus rebuild, and quickly understanding this through a very small case study. Now, if we look at these three terminologies which are very commonly used when we are reusing the old buildings or existing buildings. So, the first is refurbishment. Refurbishment is the process of returning the building or its systems to their original condition. So, we are refurbishing to return, to get back the original system of building in place. While we are more concerned with renovation and retrofitting. So, refurbishment is whichever way the building was constructed or designed, we retain that, we bring it back to the same original condition. But what we are talking about here, which is going to be more of use, and it is actually how majority of the projects in industry in practice are happening, is renovation and retrofit. What is renovation? It is the process of taking refurbishment one step forward by integrating changes to physical parameters of the building. So, we are making changes to the physical parameters beyond what was existing. The third terminology which is similar is retrofit. It is the process of replacing and upgrading the systems and technology in existing building to address its technological or environmental obsolescence. So, the example that I was giving you just now, which was of adding an air conditioning system into an existing old building, is a case of retrofitting it. So, not just one, but then we have to retrofit the entire building to advance it technologically, to add the latest technology or upgrading its systems. So, we are going to be looking at renovation and retrofit. So, going with retrofit first, there are different approaches of retrofitting, but largely when we see retrofitting, we are going to be intervening in 5 different possible parameters. One is roof. So, we can have the retrofitting of roof where we can be making changes in the structural layer itself, we can make changes in structural layer, or the ceiling beneath it, or the performance layer above it, or the protective layer on the top. So, either of the 4 layers that constitute the roof, we could be making changes depending upon the requirement. The second one is wall. So, wall could be 2, one could be the internal side where we have the structural layer and internal finish, and we could also be having the external side where we have a performance layer and external finish. For the floor, we have the structural layer, the performance layer and the surface layer, the top layer which is going to be seen from aesthetic point of view. And then we have window, within window we could be having the frames and glass, and we could also be looking at the placement of it, the orientation, the size of window, because it is easier to create a window or to close it. We can also close certain windows which are unnecessary, which are not required, or excessive windows if it has been provided. Then we have the balconies where we have the opaque part, which is often the railing. Sometimes it could be opaque, the other times it could be transparent or perforated. And then we have the transparent part, which is we are basically talking about the fenestration which is attached to the balcony. So, together we are going to make changes in these 5 areas, retrofitting them to suit, plus we have the MEP, mechanical, electrical and plumbing systems, where a lot of retrofitting measures go. Now, based on the requirement, the spatial requirement and the services requirement, the functional requirement, different approaches can be taken. So, there are 5 different approaches that we would normally see when we are going ahead with retrofitting. The first one is to replace a certain part of the envelope. So, we could be replacing an entire wall if the wall is not performing good or it has crumbled for structural reasons or whatever. So, we could be replacing an entire element, building element. That is the first approach, which is replace. And all these approaches, all the 5 approaches could be used in the same building for retrofitting. So, it is not that if we have used the replacement as a strategy, we cannot be using the add-ins or wrap it or add on or cover it. We can use all 5 of them together on different components, different building components. So, this is the first one, which is replace. The second one is add in. So, here we add new elements or materials inside the envelope system. So, the envelope is already existing and we add the new elements and materials inside. When we say wrap it, which is the third strategy, we wrap it with a second facade. So, the existing building is there and on top of that we create another facade layer and wrap the entire building in this second layer, which is wrapping. The fourth one is add on. We add new elements or materials on the outside of the envelope system. So, the envelope existed and then we add to the same envelope an additional layer, the element or material, but we are not covering all of it. We are not wrapping the entire building, but we are only adding some elements on certain facades or certain building components. And then cover it where we partially or fully cover the earlier open or semi open parts of it. So, maybe we are covering the balcony, we are covering the courtyard. So, this will be as part of cover it. Now, all of these strategies, as I said, could be used simultaneously within the same building, but on different components. Now, looking at example of each one of these, when we are talking about the replacement of a building element, of the envelope element. So, what we could be doing is, for example, there was a brick wall, but now we want to construct some load on it or an extra story on it. So, what we could be doing is we could be replacing this brick wall with a shear wall, or we could be replacing an entire wall with a glass facade. Suppose the use of this space is changing. So, and we are making an office building, converting it into a restaurant or a party hall, a banquet hall. There we might be wanting more of glazed facade for people to see from outside to inside and vice versa. So, we are replacing an entire component, that is replacement. Now, add-ins, for example, we can add thermal insulation inside. So, this will be an example of add-in. If we are adding the insulation on the outside and an entire layer is being added, that will go in add on. So, we are adding on top of it, or we may be adding a complete insulation plus the top layer, the protective layer or the aesthetic layer, the metal cladding. So, this will all go as part of add on. When we say wrap it, so it could be external insulation, but the entire building being covered using it, or it could just be say a metal sheet which is cut using CNC and beautiful patterns, which is creating an additional layer of shading, and there is a gap which is created in between to be used as corridor. So, this is wrapping the entire building using the second layer. And when we say covering, so we may be covering these spaces, courtyard or balcony, to heat them or cool them, or which was previously unheated or uncooled, non-air conditioned part. So, we cover it, and we cover it in a manner that it is now become integral to the indoors of the building. So, these are the different 5 approaches in which we can go ahead with retrofitting. Now, if you look at some generic examples, so what we could be seeing is that we have the original state of a small space here, and then we added insulation from outside. So, that is add on, and then we replaced the windows for airtightness, or we replaced the windows, and then we upgraded the mechanical systems. So, this could be a component by component approach. We could also be doing, so here what we have done, when we said insulation, we changed the entire insulation or added the entire insulation, or when we said windows, we added all the windows simultaneously. What we could also be doing, we could be doing facade by facade. So, if it is just one facade at a time, maybe we could be changing the glazing on south facade, or we could be changing the glazing on north facade and adding shading on south facade. So, like that. So, we could be doing facade by facade and then gradually adding the mechanical, the MEP systems. So, 5 different approaches, and how we go about them in a stepwise manner, that could also vary. It has to vary from project to project. There cannot be any one sacrosanct linear process in which the retrofitting would be done, because each building was serving a different purpose, is now being retrofitted for a different purpose. There could be occupants who are already occupying the building, and it is like in a phase manner that some part of the building will be retrofitted. So, okay, doing the exteriors first and then gradually moving into interiors, that too phase wise manner. So, that is what will define what approach do we take. Now, if we are really looking forward to, and why are we retrofitting? Largely a lot of retrofits are actually getting done because of the energy requirements, to reduce the operational energy requirement. And how is this operational energy requirement going to help us? This operational energy requirement reduction, when we will get a significant reduction in the scope 2 emissions. So, the moment I say reduction in operational energy requirement, we are directly reducing the scope 2 emissions. Now, there could be a question in your mind, there could be a contest that we are adding the materials, extra materials, for example, insulation, which will be synthetic. Now, there could be scope 3 emissions coming along with the material, and then we get scope 2 emission reduction. So, we are adding scope 3 upstream emissions and we are reducing scope 2 emissions. How do I balance it out? Maybe that eventually we would be getting higher emissions at the end of the building products life cycle. So, what we have to do is we have to do a proper calculation. How much of scope 2 emission savings are we getting versus how much of addition in scope 3 upstream is being added. Now, if we compare both of them together and if we actually get the life cycle emissions, the emissions over the entire life cycle of this building, we would be able to make a clear decision on what to use and what not to use. Now, the question will remain, how much of embodied energy to be taken in, and to actually become net zero, we have to reduce the embodied energy of the materials that are going in for retrofitting or refurbishment, and we have already seen the examples of all these materials in our previous lectures. Here, if we have to look at energy retrofits in a cost effective manner, then what are the steps that we have to follow? The first one is to conduct an assessment of existing conditions professionally. So, we have to clearly know where all is the extra energy going. So, maybe the HVAC plant is very old, maybe the lighting fixtures are very old, maybe there are other MEP systems which are not highly efficient. So, there could be one way which could be changing them, or when we assess we see that the structure is extremely leaky and there is a lot of infiltration that is happening, or there is a lot of heat exchange that is happening through the envelope. So, first thing is to know, assess and account for what is where, and then we identify the possibility of envelope upgrades. Can we insulate it? Should we insulate from inside or outside? Should we just add another layer? For example, there is already a 9 inches thick brick wall. Should we just add a cavity and another 4.5 inches thick brick wall on the outside, or fill it up with insulation? So, what are the possible strategies for envelope upgrade for walls, for roof, floor, balcony, windows, all component of building envelope? We identify the upgrades possible, and then we also identify the MEP system upgrades, that what are the possibilities. Maybe we could just change the pump, or we could just replace the chiller. So, what are the opportunities there? Now, each of these strategies is going to be associated with a cost, and we have to do the proper cost benefit analysis from emissions point of view and the cost payback point of view. And then we identify all the appliances, lighting and all other equipments We also evaluate what is the viability, feasibility of adding renewable source of energy. It could be solar, it could be wind, whatever is available in the at the site, and then we develop an implementation plan. So, out of those, now when we say identify the strategies, there are hundreds of strategies that are available. Now, which one to use here, which has lowest payback, which gives us the best energy efficiency and which is easily implementable. So, we are also looking at implementable strategy. When we have all of these together, we develop the implementation plan, because most of the retrofit projects will be the ones where either the occupant is going to get the retrofit done while staying, while occupying the building, or the occupant will be moving out for a short time. As soon as the retrofitting work is done, the occupant is going to move back. Only then it makes sense to retrofit for energy efficiency. So, we have to develop a proper implementation plan, that how will the retrofitting be done in a phase wise manner, and finally, we have to commission, and monitoring becomes an extremely important part, because a lot of times we design absolutely correctly on the paper, but the moment it comes to monitoring and implementation of the same thing, there due to lack of monitoring and lack of commissioning, the systems are installed in a manner that they do not perform that good, the performance which was actually planned and desired. So, that performance will not come sometimes. Now, if we look at the retrofitting techniques, there could be two. One, when we are saying retrofitting, we could be retrofitting the structure. In a lot of cases, we would need to retrofit the structure, because in retrofitting, we are also changing the usage of the space most of the time. So, we are retrofitting it to be used as some other type of the building, maybe a residential building to be converted into an office building, or an office building to be converted into a residential building, or say a recreational building, could be that. So, there could be structural changes also. So, what we would see is, we could be seeing solution strategies such as jacketing, structural jacketing of beams and columns, and the provision of extra reinforcement in the roof. So, all these are the structural retrofitting which might be required. So, not just for energy retrofit, we might be doing this for structural purposes. So, maybe that we need to add certain extra columns or move certain walls. So, additionally, if it was a load bearing wall, we may be needing to provide an additional structural beam or something like. So, this is the these are the different structural retrofitting requirements which we might be needing. Now, moving on to renovation. When we are looking at renovation, we are looking at three primary objectives. One is to increase the lifespan. Why do I want to renovate? I want to renovate because I want my building to be functional for a longer period. Continuation of this functionality has to be there. So, that is the first and primary objective, which is to increase lifespan. The second one is to reduce the demand for material consumption, and this requires the this also includes the resources such as energy and water, and then making use of new generation materials, that is we are looking at circular economy here. So, when we say renovation, the primary objective which the client would have in mind, the occupant would have in mind, is to add life to this building, so it continues to function for another another lifespan of the building. Additionally, we are looking at making it more and more efficient. As we are going forward, we have the higher energy efficiency standard or water efficiency standards, plus we also have the availability of new generation materials and technologies. So, we also have to add them into the renovation plan. So, these are the three things that we have to do. Now, how do we do that? For increasing lifespans, we are basically trying to increase the intensity of use. So, earlier, for example, as I gave you the example, if an office building has to be converted into a residential building. Why? Because the office has become redundant. After COVID, after the pandemic, probably the offices are not needed anymore. People are working from home, people are working remotely. So, the office space is now redundant and it can be converted into residential space to increase the intensity of use, which has gone down tremendously for the office building now. That could be the case. So, we are looking at increasing the intensity of use. It could be some other purpose. There might have been a warehouse, and now the warehouse is not in use as much, but the new demand is that of, say, a multi-purpose hall, which could be used for recreational purposes or banqueting or whatever. So, we might be converting one typology of space to the other to increase the intensity of use, and then we retrofit for suiting that purpose for which it is now being converted to. And when we say that we have to increase the lifespan, we have to choose the materials which also have the longer lifespan. Now, if I have, for example, wallpaper, now this might be required to be changed every few years, 3 years, 2 years, 4 years, depending upon the usage. While if we have, say, a cladding in a manner, or maybe just a simple plaster, which does not require replacement every 2-3 years. So, we are also looking at not just the space change, space retrofitting, but we are looking at materials which have a longer life. So, intensity is also increased and its life simultaneously is also increased, and what we are doing together is, through all these measures, is we are delaying the demolition. We do not have to demolish the building. So, making it structurally better, healthier, and also putting it to better use, increased intensity of use. Now, while doing that, we have to reduce the material consumption. We do not have to add on a lot of material just like a new building. So, how do we do that? We basically use the products which comply with design for disassembly. So, if you consider a brick wall, now if the brick wall has to be demolished and replaced with another wall, what will happen? A lot of this material, brick, will be broken and will not be put back into the use. Some of it will still be, but the mortar, the plaster on top of it will surely not be used back into the process. It can be used for infill, or it can be used as a subgrade or something like that, but it cannot be used back into for the same purpose. However, if we look at design for disassembly principles, the materials which comply with that, they can be installed and they can very easily be taken out, and they can be reassembled to some other form. So, these are the materials which we need to check out for and prefer to use them. Then we have to maximize the recycled content of the materials which are going to be used for renovation. So, we might be using salvaged materials or the products made out of salvaged materials or recycled materials, but at the same time having a longer life. So, we are looking at multiple factors together. For example, if we have, say, a restaurant now, or any other commercial space for that matter, we cannot have interiors which are going to remain there for 50 years. The fashion changes, the aesthetic sense and the perception of people changes. So, there we might be needing to change the interiors every 10 years, every 5 years or so. If we add materials which have a very long life, say 40 years of life, in such a scenario it is not making sense. There we would rather use materials which have a shorter life because the purpose demands so. So, we have to understand the material requirement, the requirement of the building, and then select the materials appropriately. And then the last one will be maximizing reuse. We are talking about reuse of the materials. What happens to these materials? So, we have to select them appropriately and then maximizing the reuse when refurbishing and when demolishing or taking off certain portions of the building. And the last one is to use the new generation buildings. We could be using prefabricated facades, we could be using bio based materials or products. So, newer materials are available, nature based solutions could also be there. So, market is full of these new generation materials. We have to select them on the basis of the factors which we had discussed when we were discussing about materials. So, we have to know what is the requirement and then select the material appropriately. Now, if we look at the emissions of refurbishment, a refurbishment project versus a rebuilt project which has been demolished and completely built from scratch. So, what we see that if we retain, it will have the lowest emissions or embodied energy. So, retain is the best strategy to be on table, followed by we refit it, retrofit it, and then next, which will require more energy, is to refurbish. Then is to reclaim or reuse. So, demolish certain parts of it and then reclaim and reuse it and then remanufacture it. And the last one is to fully recycle or compost. So, we are basically looking at all these strategies somewhere or the other, but the best is to retain. So, if we retain a large part of the structure of the building, we are actually looking at tremendous savings in terms of embodied energy. But if we further have to go, we will look at some of these strategies. They could be in stepwise manner or depending upon the purpose, but they will still be lesser than if we say completely demolish and dispose of the waste and procure new materials and rebuild, construct the building absolutely new. But if we know that this is how it helps the environment and economy and everything, then why are things not happening? Why are we not going for more and more retrofitting and refurbishment projects, and there is a lot of new construction which is coming up? So, it is for several reasons, but the primary reason for building new is that it gives you absolute control over the systems. One, they suit your function of today. So, it will be designed and constructed for the purpose that is going to be served today, plus it gives you a lot of control over the implementation execution of the project, which is not there when we go for renovation projects or retrofitting projects. The second thing is that when we are building absolutely new, it will be from scratch and on a new site. So, the existing operations will not be hampered, while with retrofitting projects or renovation projects, the ongoing operations will be hampered. So, we might be doing it in phase wise manner and there will be a lot of shifting and shifting back which might be required. So, often people go for these new building projects and avoid renovation, but there are a lot of advantages with renovation projects, which is that it is much lesser expensive to construct than to construct an entirely new building and to furbish it as per the requirement. So, it saves the client, the occupant, a lot of money if we are going for renovation or retrofitting. The other thing is that if we are renovating and retrofitting some very old historical building, it will add the charm which the new building can never have. So, if you will go to a lot of old cities, historic cities, you would find that majority of the old buildings have been retained and they have been refurbished and retrofitted. So, retrofitting and refurbishment is very common for buildings or cities where more historic buildings are there, which can never come with a new building. So, with these pros and cons, we have to decide what would be the best strategy for us. If we overall look at the carbon dioxide emissions which are associated, we clearly can calculate based upon the material that is going to be put in. For a new building, how much material is going to be put in, and then we already know the emission intensity, we already know the carbon footprint of each material, we have databases, and then we can compare it with the refurbishment. So, there is going to be tremendous multiple folds, multiple times the emissions that are going to accrue from the new buildings, and this is over the life cycle of the carbon emissions for newly built and the refurbished buildings. So, we will see that the refurbished buildings will be significantly lower throughout its life cycle than the new building. So, we will be adding a lot of embodied carbon from refurbishment, or we will be adding some amount of carbon from refurbishment, but if we are completely constructing, this entire initial block of embodied carbon will be added to the new building. Now, if we are looking at the refurbishment project, any refurbishment project or any building project for that matter, because every building as a product will have some limited life, but not all the systems within the building will have the same lifespan. So, we have to clearly know what are these different layers and how much lifespan do they have. So, for example, the stuff which is there, the furniture, the furbishment, curtains, wallpapers and all these, this stuff is difficult to predict what life it has. It depends upon the client, how frequently one could be changing them frequently or may not change them. So, it is difficult to predict, but if we look at the space plan, it has a lifespan of 3 to 30 years depending upon the building type. So, even the spatial planning will have certain life, it changes, even the residences change, within the residence the spatial planning will change. Then come the services which are next, which have a lifespan of 7 to 15 years, lesser than the spatial planning too. Then we have the skin, which is the outer skin, which has a lifespan of around 20 years. We have the structure which has the maximum lifespan compared to all these, which is approximately 60 years. We could be taking it higher up to 100 years or 120 years depending upon what materials are we using. So, depending upon specifically the materials, if you go to some old forts and castles across the world, you would see that they have been standing there for 800 years, 1000 years. That is by virtue of the material that has been used in these. So, the structure could be, but it is still the highest, and looking at the materials which are conventionally used in today's times, including steel and glass, the structure is going to be approximately 60 to 100 years. And then we have site, which is going to be there forever. It is eternal, it has an eternal lifespan. Now, why we are looking at this is, we look at the materials that are going to be used for each one of these. So, if we are talking about services, we know what materials are going into services. We can't plan services for eternity. This building is not going to be there. The services are going to be replaced much sooner than the life of the building. So, what kind of materials should we select for services, or what kind of materials should we select for structure or for skin? This is what we have to know and we have to clearly understand. So, there was this study which was research which was done to predict total annual energy consumption of UK housing sector by applying a step by step retrofit approach. So, if we look at the existing demand, it is here, which is the current demand. Now, the first, as a first retrofit step, what was proposed was, what was considered, not proposed, was replacement, retrofitting of windows and ventilation. That would bring around 42% of the savings. If to this window and ventilation strategies, if we add roof and floor insulation, it will give an additional 3% saving, not much. And then if we are looking at adding exterior wall insulation, it will further give us another 3%, 5% savings. And on top of these, if we add renewables, it will give us, it will bring down to another almost 30% savings. So, total bringing this existing energy demand down by 87%. So, retrofitting strategies, retrofitting techniques will have tremendous potential to save the operational energy at some incremental cost of the embodied energy which will be going into the refurbishment. Now, quickly looking at a case study. So, what this particular case study did was that there was a 2-story office building and the facade looked something like this, and then the intent was to add one more story on top of this floor. So, instead of 2 stories, it was intended to make it 3-storied building and then redo the facade and make it an open plan. So, what was done was that the structure was retrofitted because the columns needed to be strengthened structurally to hold one more story on top. The entire structure, not just columns, but beams and slabs and everything, and one more story was constructed on top of this. For the existing ones, the plan was opened up and the interiors were added with insulations and the facade was changed. So, after refurbishment, the building footprint on ground remained the same, it did not change For the same structure, structural retrofitting was done to accommodate one more story, plus the retrofits were made in terms of, for example, the services, the lighting. So, it served from a previously conventional office building, it was converted into an open plan office building, which was more functional for the modern day need. It had better lighting and it had better ventilation. The equipment which were retrofitted, the upgraded equipment, they were more energy efficient. So, despite adding an entire floor of approximately 3000 square meter, it still had almost the same amount of operational energy requirement. So, that was the achievement of this refurbishment project, that despite adding one entire floor, they could still retain the energy consumption to pretty much the same, the operational energy requirement at a minimal insignificant refurbishment embodied energy that was added. So, if we calculated over the life cycle of the building, this addition of energy and thereby emissions was much lesser than the operational energy savings which were accrued in this entire process. So, I hope with this you have understood the idea behind refurbishment and retrofitting for the existing buildings. The principles remain the same, the passive design principles, the factors affecting material selection and the emissions attached with associated with materials, all these principles remain the same, but instead of applying them to a new building, we are applying them to for retrofitting and refurbishment. I will stop here and we will look at some of the case studies for the projects, not refurbished projects, but new projects, to understand the whole idea of scope 1 and 2 emission reduction through building design and construction in the last lecture of this week. Thank you very much for joining me today. Bye bye. See you tomorrow.